Hi everyone! We're going to talk about parent functions, and after that we're going to talk about transforming these parent functions. So first one that we want to talk about is called y equals x. And you should know the name of this function. If you don't, let's just get this down. It's called a linear function. A linear function obviously is just a line. And so when I create a table for a linear function, I'm just going to put the coordinates -2, -1, 0, 1, 2. Well, if you actually read this, it says y is x, or y is equal to x. Y is the same thing as x. So now in this column right here, I can just say, oh, if y is the same thing as x, I can say -2 here, -1 here, 0, 1, and 2. Remember, when we plot coordinates, we always do the x value first. So for example, if I'm plotting the point -2 and then the point -2 here, this is always the left, right, and then this would be the up, down. It's always the x coordinate first and then the y. So for this one, I'm going left 2, because negative means left, and then down 2. So that's left 2, down 2. The next coordinate is going to be left 1, down 1. Remember, it's always left, right first, then up, down second. So left, right, left 1, down 1. 0, 0 means you're going left, right, 0, and up, down 0. So that's right here. Okay, we've done that one. Now let's go ahead and plot 1, 1. Well, 1, the first one is going to be right 1 and then up 1. And you can start to see this pattern, and if you already saw it, you can just go ahead and get that down. And I really want you to get in the habit of drawing the line through these points and putting arrows. And the reason why is because the arrows indicate that they go on for a long time, or forever, really. The characteristics of a linear function is that it is just a line. All right, let's go ahead and take a look at the next parent function. Right, a parent function is just these big overarching general functions that are really big in mathematics. So the next one I want to talk about is y equals x squared. So y equals x squared, let's go ahead and just do the same thing here, -2, -1, 0, 1, 2. This will be consistent for the rest of our lesson. Well, in order to get what the y values are, we actually have to plug this x value into this equation. So the first thing I'm going to do is have y equals a parentheses. Anytime you're plugging in, you're going to put parentheses, and then don't forget your squared. So what is -2 squared? Well, if you're going to do this in your calculator, you need to put parentheses. So -2 squared is -2 times -2, which is just simply 4. All right, so I'm going to put that right here. The next one is going to be y equals, and this time I've got -1 squared, which is just -1 times -1, so that's a 1. Now I'm plugging in 0. I'm just using these x values right here, and I'm going to get y equals 0 squared. That's 0 times 0, that's 0. And then I'm going to do the same exact thing for these last 2 points. And since I already have it written in there, I'm just going to use that kind of format. So now I'm going to plug in 1, because I'm here. 1 squared is 1. And now I'm going to plug in 2. 2 squared is 2 times 2 is 4. Here's a quick note, all right, if you might want to write this in your notes. A note in your notes. 4 squared is equal to 16, because remember, 4 squared is 4 times 4. 4 squared is not equal to 8. It is not 4 times 2. That is wrong. Wrong, 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 wrong. Okay, so when you see that squared, make sure it's multiplying it by itself. In other words, 4 times 4 in this example. All right, now we're ready to go ahead and graph these. And so for the first one, I've got a left 2 and an up 4. So left 2, up 4 leaves me here. Then I've got a left 1, up 1. Then I've got a 0, 0, which you could call that the origin. Then we've got 1, 1, which is right 1, up 1. And then we have 2, 4, which is right 2, up 4. You're going to go ahead and connect these points, draw your arrows, and that is what we call a parabola. Okay, the characteristic is a parabola. It is a happy face. And then sometimes we will have a sad face if we have a negative out in front, but we will talk about that later. All right, the next function I want to talk about is y. Oh, look, we kind of switch the sides here. We'll go over here, is y equals absolute value of x. And this is called the absolute value function. Thinking I might have forgotten to name the other one, so let me go back for a second. The name of this one is the quadratic function. So let's go ahead and name that. That's the quadratic function. All right. Going back to this absolute value function, the definition of an absolute value is the distance away from 0 on a number line. So what I mean by that is if I have a number line and I have the number -3, how far is -3 away from 0? Well, it's 3 units away, so the absolute value of -3 is 3. What about 1? How far is 1 away from 0? Well, it's also just 1 unit away. So the absolute value of any negative number is positive, and the absolute value of any positive number, it's also positive. So let's just go ahead and fill in this. We've got -2, -1, 0, 1, and 2. And let's take the absolute value of these x's. So the absolute value of -2 is 2. The absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So let's go ahead and graph that. Looks like this. It almost looks like a line with a negative slope on the left and then a line with a positive slope on the right. And I'm going to go ahead and connect that. And please make sure you have your arrows. And the characteristics of that are that it's a V shape. So our takeaways here are that this function is called the absolute value function. It's a V shape, and we should know that the absolute value of a negative is a positive, and the absolute value of a positive is also a positive. All right, last function we're going to talk about is going to be the absolute value function. So that's going to be this one. Oh, excuse me, the square root function. Silly goose. So y equals square root of x. Y equals the square root of x is the square root function. Remember, a square root is the opposite direction of squaring something. So for example, maybe let me not write that here. For example, if I want the square root of 9, that's equal to 3. Why? Well, because 3 times 3 is equal to 9. What's the square root of 25? Well, that's equal to 5. Why? Well, because 5 times 5 equals 25. So that's what a square root is. And this one's a bit trickier in terms of picking the x's and the y's, but just trust me here. We're going to choose 0, 4, and I think we're going to choose 9, and that's it. Actually, you know what? I'm going to add 1 to it. Why not? So the square root of 0 is asking what number times itself gives you 0. Well, that's going to be equal to 0. Why? because 0 times 0 equals 0. Now, what's the square root of 1? Well, that's equal to 1. Why? Well, because 1 times 1 equals 1. What's the square root of 4? Square root of 4 is 2. Why? Well, because 2 times 2 equals 4. I hope you're getting this. And what's the square root of 9? Hope you said it out loud to yourself, or maybe quietly. It is 3. How come? Well, 3 times 3 equals 9. So I'm going to put that there. So we're going to go ahead and we're going to graph these points. 0, 0 is here. 1, 1 is here. 4, 2, 1, 2, 3, 4, 2 is here. And I can't fit 9, 3 on my graph, but you know, it would be kind of somewhere out here, if you will. Actually, I guess technically down a little bit more, like here. So what does the square root graph look like? It looks like that. There we go. All right, one more slide. I want to talk about translating parent functions. So for example, if I had the graph, the square root of x plus 1, this brings my graph up 1. If I had the square root of x minus 1, this is the opposite of what you think it is. It's actually going to bring the graph right 1. Now what if I had the square root of x minus 3? Well, that's going to bring the graph right 3. And what if I had the square root of x minus 4? This is going to bring the graph down 4. What do you observe here? Well, notice how the plus 1 is on the outside, and that's going to be an up 1. Notice here how the minus 4 is on the outside, that's a down. So a summary is if I have a number on the outside, it's going to be an up or a down. And it's exactly what you think it is. So in other words, if you see a plus, you would think up, right? If you see a minus, you would think down. That's what I mean by it's exactly what you think it is. All right, so that's the first piece of my summary. The second piece of the summary is talking about left and right. If you see a number on the inside, it's going to be a left or it's going to be a right shift, and it is the opposite of what you think. So for example, you see a minus, you would probably think left, but it's not. It's actually going to be a right 1. If you see a minus 3, that's going to be a right 3. So let's go ahead and let's do a couple examples before we go ahead to the graph. And this time I'm going to use the parent function of a squared function. So for example, I'm going to go ahead and choose x plus 5 quantity squared plus 2. First thing to say is, hey, I know that this parent function is going to be a quadratic. How do I know that? Well, I know that because I see the square. I know that that's going to be a smiley face. What I now need to say is it left, right, up, or down. Well, we know on the outside the number is an up or a down. In this case, this is going to be an up 2 because it's on the outside and it's plus. Now we have a number on the inside saying plus 5. That's going to be a left or a right. It's the opposite of what you think. So plus 5, I'd think right, but actually this is going to be a left 5. So I'm going to do this problem, and I'm going to graph the original, and I'm going to use my parent function color. I'm going to be green. It's going to be my parent function. That's going to be y equals x squared. So I'm just going to graph that as 0, 0, 1, 1, negative 1, 1, 4, 2. Oh, that's not it. Rats. Oh, no, sorry, 2, 4, silly me. Just right here. This is my parent function in green. But after seeing here that I'm going left 5, because it's inside the parentheses, or inside the grouping symbols, and then an up 2, I'm going to go ahead, I'm going to graph that function. It's no longer a parent function because I've translated it. I'm going to graph it in blue. Okay, so I'm going to highlight this in blue. And you might think, whoa, I don't know how to do that, but all you need to do is take these green points and you need to move them up 2 and left 5. So I'm going to go up 2 and left 5. So I'm going to go up 1, 2, left 1, 2, 3, 4, 5. And that point right here just went up 2 and left 5. And don't draw what I just did, but I was just trying to visualize that. All right, I wish there was an undo there. I'm not sure there is. It just kind of disappeared on me. All right. All right, so now let's go ahead and let's move, let's move this point. We're going again up 2, left 5. 1, 2, 3, 4, 5. There it is right there. Okay. And I'm going to go ahead, I'm going to do that same thing with all other points. Left 2, up 5. Oh, I went opposite, right? It's up 2, left 5, up 2, left 5. Here we are. I'm going to go with this one, left 5. 1, 2, 3, 4, 5, up 2. Here we are. I think I'm missing this one right here. Left 5. 1, 2, 3, 4, 5, up 2, 1, 2. There we go. I think I said that wrong a couple times, but basically you're taking every single point and you're going left 5 and then up 2, or you could go up 2 and left 5. And so I have it here, right? In blue, this is my function x plus 5 squared plus 2. And in green, I have just my parent function, which is y equals x squared. All right, thanks for following along. We're going to do plenty more with translating parent functions. This is absolutely not the last time you've seen it. Thanks for watching, everyone.